In this next lesson for Homework Packet 1.3, we're going to take a look at simplifying radicals. So let's look at our first example here. Now, what we're going to be looking at first in this lesson is simplifying a single radical statement like we see right here. It's just one radical statement. I'm not doing plus another, times another, divide by another. It's just a single radical statement. Now, simplifying a radical expression involves removing, here's the key, removing as much as possible from underneath the radical. The goal is to remove as much as possible from underneath the radical. So here's our piece underneath the radical. The question is, how much of this can I remove or get out from underneath of the radical? There's a couple different approaches we can take in regards to removing stuff from underneath a radical. I have 5 times the square root of 28x to the 4th h to the 3rd. So there's significance to the fact that this is a square root, because what that square root is implying is that I can remove pairings from underneath the radical. Here's what I mean by that. I'm still going to have this as 5 times the square root of what? What I want to do is I want to break down the 28 as much as possible. So the 28, I'm going to come over here to do that. The 28, I could split it up into 14 times 2. And then the 14, I could split up into 7 times 2. So 28 is nothing more than 7 times 2, which is 14, times another 2, which is 28. So I can write this as 7 times 2 times 2. And then I'm still going to look at it as x to the 4th, h to the 3rd. With the numbers, here's why this is significant. This being a square root, I know that I can remove pairings of the same number being multiplied together. So I see a pairing of 2's here. What that means is I can bring a single 2 out of the radical. So this becomes 5 times 2, because a 2 is able to come out because that there's a pairing. One way you can think about this is 2 times 2 is 4. 4 is underneath a square root. What's the square root of 4? Well, it's 2. So a 2 came out. But now let's look at the x to the 4th. Think about it in terms of the exponent, x to the 4th. If I have 4 multiples of x, how many pairs, because remember it's a square root, how many pairs of x's do I have? Well, realistically, if I have x times x times x times x, which is x to the 4th, I have 2 pairings of x. That means I can take and bring an x squared out, because I have 2 pairings of x. So we've brought the 2 out, we've brought an x squared out. Now let's look at this h to the 3rd. H to the 3rd is h times h times h. This one's a little interesting because I do have one pairing of h, but I have nothing to pair this last h with. It's on its own. But since I have one pairing of h, I know that I can bring an h out. But what do I still have left under the square root? I still have that lone h sitting underneath that square root, the h that had nothing to pair up with. So this is what I was able to bring out. Simplifying it real quick, 5 times 2 is 10, so I end up with 10x squared h times the square root of h. I was able to bring a 2 out. Oh, you know what I missed? I had the pairing of 2's, but what number is still under there? A 7. So it's actually 7h still under the radical. So the number I was able to break up into 7 and a pairing of 2's, which meant a 2 could come out. 5 times 2 gives me the 10. The x's, I had 2 pairings of x. Therefore, an x squared came out. The h's, I had a single pairing of h, so a single h came out. But what are the pieces left that didn't have a pairing? The 7, as we said, and the h. So a 7h is still left underneath the radical. So this is my final simplified radical. I brought as much out as possible. So let's take a look at another example just to solidify some of those concepts. I've got -6 times the square root of 75 j to the 9th p to the 5th. I'm going to look at that 75 real quick. And I'm going to start breaking it up. 75, I could break that up into 25 and 3. And the 25 I could break up into 5 times 5. So 75 is 5 times 5 times 3. I see that in this grouping here, I have a pair of 5s. So I'm able to bring a 5 out. So I'm going to start this as -6 times 5. But I'll have to remember that I still have this 3 left under the square root. What about the j's? J to the 9th. That's j times j times j times j times j times j times j. Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 j's multiplied together is what j to the 9th is. I see that I have 1, 2, 3, 4 groupings. Another quick way to think about this is because we're a square root, how many times does 2 go into 9? Well, it goes into 9 4 times, but then as we see over here, 1 left over. So a j to the 4th can come out, but I have to remember that I've got that j left. What about the p? That's to the 5th. P times p times p times p times p. How many pairings do I have? I have 2 pairings. Or how many times does 2, my radical, go into 5? Well, it goes into it twice with 1 left over. So a p squared comes out. And what's left under the radical? I have the 3, a j, and a p still left underneath the radical. So I'm going to do my -6 times 5 to get -30. I have a j to the 4th that I was able to bring out, p squared that I was able to bring out, times the square root of 3jp, which I can't bring out. So here is my simplified radical. This last example we want to look at in this video is a little different than the rest because it's not a square root, but it's a third root. So be careful and pay attention to the fact that it's a third root and that some of the problems in your homework packet are going to be third roots. So this is the third root, 7 times the third root of 54 m to the 6th b to the 11th. So here's what we need to adjust in our thinking. Instead of bringing out pairs because it's a square root, I can only bring out triplets because it's a cube root, a third root. So let's first start with this 54. How could I break up 54? Let's see, I think 2 goes into 54 27 times. So 27 times 2 is 54. The 27, I could break that up into 9 times 3. 9, 18, 27, yeah. You could break the 9 up into 3 times 3. What I see here is that I have a triplet of 3's. And that's what I'm looking for because I'm dealing with a third root. But I still have this 2 left over right here. So because I have a triplet of 3's, a 3 is able to come out. So I have 7 times 3. What about the m? It's m to the 6th. M times m times m times m times m times m. There's my 6 m's, m to the 6th. Now again, I'm not looking for doubles anymore. I'm looking for triples because it's a third root. I have 2 sets of triplets. So an m squared, the 2 meaning I have 2 sets of 3, is able to come out of the radical. What about the b to the 11th? Okay, the concept here, I'm not going to write out all the b's this time. Hopefully you see the concept. How many triplets can I get out of 11 b's multiplied together? Let's think 3, 6, 9. I'm able to get 3 triplets. And that means I used up 9 of the b's. If I used up 9 out of the 11 b's, it means I have 2 b's left over. So what is left underneath this third root? The 2 is left under the third root, and because I only used up 9 of the 11 b's, that means I have 2 b's, b squared, 2 multiples of b squared left over. So out here, the 7 times 3 is 21. M squared, because 2 sets of 3 were able to come out of m to the 6th. B to the third, because 3 sets of 3 were able to come out of the b to the 12th, times the third root of, we got that 2 left over, and then the b squared, because 2 multiples of b were left over after taking out the 3 sets from the 11. So our radical expression simplifies to 21 m squared b to the third times the third root of 2b squared.